In each of 1 and 2, functions f and g are defined by arrow diagrams. Find g of f and f of g. I say the word of, but obviously I don't mean multiplication here. This is the composition of functions. And determine whether g of f equals f of g. Let's start with g of f, which, keep in mind, g of f of x is defined by g of f of x. Let's just unpack what's really going on here. X is the input variable, specifically of f. F of x is technically two things. It's super important to understand that f of x represents two things here. On one hand, it represents the output of f of x. So this is the output. This represents the output of f. But on the other hand, it also represents the input of g. And the reason it's the input of g is because that f of x is in the parentheses belonging to the function g. So that means f of x is the input of g. We're plugging f of x into g. And then lastly, this entire thing represents the output of g. So when I look at this picture, I really see four things. Really, there's three things, but one of those things has a dual nature to it. On one hand, f of x is the output of f, but on the other hand, f of x is the input of g. So here I've drawn the sets x, x, and x. These are all the same set x, but I've used the same coloring that I used in this diagram here. Notice the very inputs of this function is red, and we're starting with this set on the left here, which is red. The middle set here has a dual nature to it. On one hand, it represents the outputs of f, but on the other hand, it represents the inputs of g. And that's why it's purple here. And this last set is green because it represents the outputs of g. So this is just a way of visualizing what's really going on. Notice the difference between the original problem and what we have so far. The original problem shows two separate maps. When you compose functions, that means that you have to essentially stitch those functions together. In this case, that's the purple set here. Now we're going to draw the same functions for f and the same function for g, which looks like that. And then g is going to look exactly the same. 1 goes to 3, and so on. Now this is a composition. If you notice, from the left, the input 1 gets mapped to 5, and then it gets mapped back to 1. The number 3 gets mapped to 3, and then it gets mapped to 5. The number 5 gets mapped to 1, and then it gets mapped to 3. The composition of f and g is really a relation between the first set and the last set, the red set and the green set here. Now this purple set, I think, plays a very important role for understanding what the composition is. But ultimately, the composition is just a relation between two sets. Here we have a drawing with 3 sets. But now I'm going to redraw this. Here we have the red set and the green set. Notice the purple set is gone. The reason the purple map is gone is because the function composition is a relation between two sets, only two sets. The way we identify this composition is by essentially following the path through the purple set. So if we start at 1 here, and 1 is mapped to 5, and then 5 is mapped to 1 again, then really 1 is just mapped to 1. The 1 from the red set is mapped to 1 in the green set. 3 is mapped to 3, and then 3 is mapped to 5. So 3 in the red set is mapped to 5 in the green set. 5 is mapped to 1 in the purple set, and then 1 is mapped to 3 in the green set. And so this is the function composition. This relation here is g of f. And again, notice the ordering here. G is first, f is second, even though in this visual diagram, f is first and then g is second, which can be a little confusing. Now we have to find f of g. The only difference is the order that we arrange these maps together. So we're going from x to x again, and then from x to x from there. But the maps are g first, then f. The ordering is a little backwards from how it's written here. This g is the same function. 1 gets mapped to 3, 3 gets mapped to 5, and 5 gets mapped to 1. So we're going to draw that same relation. And then f is the first function. 1 gets mapped to 5, 3 gets mapped to 3, 5 gets mapped to 1. And so that's what F looks like. The composition is really a relation between two sets. It's still from X to X, but notice this visual map will only have two sets. If we notice in the visual diagrams that we stitch together here, 1 gets mapped to 3, and then 3 gets mapped to 3, so 1 gets mapped to 3. 3 is mapped to 5, and then 5 is mapped to 1, so 3 is mapped to 1. 5 is mapped to 1, and then 1 is mapped to 5 again. That should be a 5. Then that means 5 is mapped to 5. And so this is what f of g looks like. We're supposed to draw an arrow here, and this is the name of the function. At the end of this question, it asks, determine whether g of f equals f of g. So we just have to look at this visual diagram and compare it with this visual diagram and ask if they're the same visual diagrams. Well, if you notice in g of f, 1 is mapped to 1, but in f of g, 1 is mapped to 3. In function notation, we would say that g of f of 1 equals 1 here, since 1 is mapped to 1, and f of g of 1 equals 3. So f of g of 1 equals 3, g of f of 1 equals 1, which means that g of f of 1, which is 1, is not the same thing as f of g of 1, which is 3. This means that f of g and g of f are not the same functions. To be the same functions means that they are literally the same relation. We'll get into what a relation is eventually, but really it has to be the same relationship between the first set and the second set, meaning that if we plug in an element into one function, it should be the same output as if we plug that input into the other function. Those should be the same outputs because they're the same inputs. So when you plug in the same input into both functions, if they're the same functions, you should get the same output. Here we have an input that we're plugging into both functions, but we get different outputs. And so because of that, these are not the same relationships between the inputs and the outputs. Or in other words, they're not the same relation, which we'll get into eventually in the next chapter. Anyways, thanks everyone, and I'll see you in the next video.